Solomon. This is for Tuesday's lesson, and so the papers that you're going to need is called Modeling Ratios, and then the Modeling Ratios cards, and then the Science Fair. Science Fair was the homework.
Hello.
Hi. Can you come back in just a minute? Thank you. So what we're doing is we're talking about ratios today. We're talking about ratios, and ratios can be either part to whole, and that's kind of the fractions that we've been doing probably since kindergarten, right? We're comparing part to the whole amount. We can also have a ratio that compares part to part. In a ratio, there is always going to be two parts, and then there will always be a whole. So let's get started and let's talk about it, because it'll probably make more sense if I can use an example. So this modeling ratios paper goes with these cards, and so they had done the first one for you, and that was summer job. Jake mowed lawns this summer to earn spending money. For every $10 Jake earned, he decided to save $4. So what we talked about is that the $10 is the whole part of my situation that I'm in, and he decides to save $4, which is a part of my situation, but there's a part that's missing, and the part is the $6 that he spent. So if I was going to use Cuisinart rods to represent that, our whole amount would be our orange, which stands for 10, and our saved amount, which would be $4, which would be purple because that's 4 units long, and our spent amount would be $6, which is my dark green. And that's what is shown right here, is $4 saved, $6 spent, $10 earned, okay? So we're going to work on how to write ratios today. And so first of all, we want to talk about a table. Yesterday's lesson was all about multiplicative thinking, right? And additive thinking. Ratios are always going to be multiplicative thinking. It's always going to be doubling, tripling, halving, taking a third of something, whatever it might be. So in this case, I want to show if one group is a purple, dark green, and orange, I want to add another group of purple, dark green, and orange. So now if I have two groups of 10, I now have $20 earned. If I have two groups of 4, I have $8 saved. And if I have two groups of 6, I now have $12 saved. Notice that this is multiplicative thinking because I went from 10 to 20, I doubled that number. I went from 4 to 8, I also doubled that number. And to go from 6 to 12, I also doubled that number. Notice how I multiplied by that constant number of 2. That constant number of 2. Okay? What if I added another group of the purple, green, and orange? What would it be? It would be 3 groups of 10 is 30, 3 groups of 4 is 12, and 3 groups of 6 is 18, right? Okay, so what we did is we looked at, well, now it's still multiplicative because with the original, it was 3 groups. I was tripling, multiplicative thinking, okay? So now we want to talk about our ratios and how to write them. So you heard me say that ratios can be part to whole, so I'm just going to say PT to WH. So part to whole, so let's understand my part to whole. Here are my 2 parts, and here is my whole. So what I want is, I want one of my parts to my whole, or I want my other part to my whole. And in this case, it's money saved to, in this case, earned. I'm using these initials right here, okay? So SA stands for saved. And so money saved to my money earned. So the money saved was 4 to the money earned was 10. 4 to 10. So you might be asking, well, Mrs. Ankley, this looks like a fraction or a ratio that can be put in a simpler form. And the question is, can I do that? Well, you know how we doubled here? We doubled here. Didn't we say we can also divide by a common number as well? We can divide by a common number. So let's see if we can divide each of these in half. If I divide an orange in half, it's a yellow. If I divide the purple in half, it's a red. And if I divide the dark green in half, it's a light green. So would this be an equivalent ratio? I took this and took half of it, or divided by 2. I took this and divided by 2, and I took this and divided by 2. Do I still have the same ratio? Do I still have that multiplicative thinking? And the answer is yes, I still have that multiplicative thinking. So we can say that it is also 2 to 5, 2 to 5 saved, okay? So that's one of my part to wholes. Every ratio will always have 2 part to wholes. One is saved to earn, the other is spent to earned. So instead of doing purple to orange, now we're going to do this dark green to orange. So the number spent is 6 and the earned is 10. So now it's going to be, what is it up here? Now that I divided by 2, it's going to be 3, 2, 5, right? Notice how I'm not saying 3/5. I'm saying the word 2. That's all about ratios. I'm comparing two things. That's what a ratio is. I'm comparing two things to each other. It might be money saved to money earned, money saved to money spent. It could be boys to girls, apples to oranges. It could be anything that we have, okay? So that's my two relationships between part to whole. We can also have part to part. Now, this is a little bit different than what we've done with fractions. Fractions have always been part to whole. It's always been how much is shaded out of the total number of pieces. So now with ratios, we can do it another way, and that would be, instead of considering my whole, I can do part to part. So I can do the money saved to the money spent, which would be 4 to 6, which would be, if I simplified that to lowest terms, do you agree it would be 2 to 3? That means for every $2 I save, I spend $3, okay? So that is saved to spent. Well, if I do saved to spent, I could also do spent to saved. Spent to saved. Notice how I'm also writing what it is that I'm comparing. That's a really, really important part of ratios, telling me what it is that you're comparing. So spent to saved would now be 6 to 4. 6 to 4, if I want it in simpler terms, I could say 3 to 2, right? Now you might be thinking, Mrs. Angley, that looks like an improper fraction. So if we're simplifying fractions, would we also make these into mixed numbers? And the answer is no, we would not, because remember what a ratio is. A ratio is a comparison of two numbers, two things. If we simplify this down to 1.5, we have now lost our ratio of a comparison of two numbers. So we would just leave it as that, $3 spent to every $2 saved, okay? All right, so the next one that we did was a juice recipe, okay? So this is the juice recipe. So let's see what it says. A new juice recipe calls for 3 cups of apple juice for every 2 cups of grape juice. Now remember what I said about a ratio. A ratio will always contain 2 parts and a whole. So we have to decide, does this information that's given, does this represent parts, whole? Does it represent 2 parts? Let's see if we can figure it out. So a new juice recipe calls for 3 cups of apple juice for every 2 cups of grape juice. So let's jot that down. 3 cups of apple juice, 2 cups of grape juice. Do you agree that those sound like 2 parts of the recipe? So part and part, and so now what would my whole be? It would be 5 cups of, we're going to call it punch, P-U-N for punch, okay? What does that look like with my Cuisinart rods? Well, a 5, my whole is a yellow. My apple juice is a light green, and my grape juice would be a red for 2. Okay, so let's draw a picture of what that looks like. So here would be my yellow. This would be my 5 cups of punch. And my 2 parts would be, let's see, that looks like about right. So my this would be my 3 cups of apple juice. And here is my 2 cups of grape juice. Okay, do you notice over here they put the whole first and then they did the 2 parts? I'm just going to stick with that relationship, that pattern. You don't have to, but it's just, you know, it's always just good to kind of keep it in line. So I'm going to label this as punch, this is my apple juice, this is my grape juice. So let's see if we can make these relationships, this table. So for every 5 cups of punch, I need 3 apple juice and 2 punch. Okay, so that's like one recipe, right? So let's say we make 2 recipes. So instead of having 1, I'm going to repeat that recipe again, right? So what would my new row in my table be? So it would be 10 cups of punch, right? 2 groups of 5. It would be 2 groups of 3, which is 6 cups of apple juice, and 2 groups of 2, which would be 4 groups of grape juice. Notice how I doubled, right? That multiplicative thinking. Ratios are all about multiplicative, right? I doubled 5, I doubled 3, I doubled 2. Okay, what if I did a 3rd group? So I would not double, but triple. I would triple 5, I would triple 3, I would triple 2. Notice how the 9 and 6 still make those 15 cups of punch, okay? Let's see if we can do part to whole on this. Part to whole. Now let's take a look at what my part to whole is. Here's my 2 parts. Here's my whole. So do you agree that I can compare, this is my apple juice to my punch. So the first one would be apple juice to punch, and that would be 3 to 5. Okay, what's my other part to whole? See if you can do it. Do you agree it would be grape juice to punch? And that would be 2 to 5. Okay, so those are my 2, and I'm going to outline them just so you can kind of see them. So those are my 2 ratios for part to whole. Let's see what part to part would be. So this is where I take my 2 parts, so my green and my red, right? So do you agree that I can do grape juice, well, it could be grape juice, apple juice to grape juice, which would be what? 3 to 2, right? And do you agree we're going to keep it like that, right? Because we want that ratio. And then the other one is grape juice to apple juice, which would be 2 to 3. Okay, so those are my ratios. So here's what I want you to do. I want you to see if you can figure out championship teams. That says, over the past 10 years, the Spartans volleyball team has averaged 5 wins out of every 7 games played. So remember what I said, there's always 2 parts and a whole. So there's something missing here, and our job is to figure out what is it that we have and what is it that we're missing. Okay, so do you agree that 5 wins is obviously part of my part, right? Because that is the smaller number. So that's a part. But now we have to figure out, is 7 games another one of my parts, or is it my whole? Hopefully you're saying it's my whole, because it's 5 wins out of every 7 games. So 5 wins out of 7 games, and so we're missing a part. So in a game, you either win or you lose, right? So what we're missing is we're missing my 2 losses, right? So I will build this for you because you probably don't remember that the 7 is the black, and the 5 is the yellow, and the 2 is the red. So I want you to pause the video so that you can go ahead and see. I want you to draw the picture, I want you to fill out the table, and I want you to see if you can do all 4 of these ratios for me with this example. Okay, so pause your video so that you don't get to see the answers. Okay, so hopefully you got my answers. You shared your answers with me. And so I doubled the 7, 5, and 2 to get the second line, and then I tripled the 7, 5, and 2 to get the third line. And then there, of course, is your part to whole, wins to games, losses to games, wins to losses, losses to wins for your 2 ratios. So I want you to do the next one on your own, and that is the, let's do the classroom dynamics. Okay, so Mr. Mendez's first period math class has 2 boys for every 4 girls. 2 boys for every 4 girls. So I want you to think about if that is that part whole. So see what you can do with that. Try to draw a picture. You probably don't need your Cuisinart rods, but see if you can draw a picture, and I'll be back with the answers in just a minute. Okay, I discovered without my Cuisinart rods I couldn't draw a very good picture, so I made a few mistakes. Okay, so let's hope that your table matches. The thing I wanted to point out to you over here in the part to part is that the girls to boys was 4 to 2, and notice how I did leave this as 2 to 1. We wouldn't go ahead and say 2 there because, again, we would lose that ratio of a comparison of 2 things. So we would say 2 girls for every 1 boy. So we would leave it as 2 over 1. Okay, so that's kind of the lesson that it was. We only really got that far, but you do have some other examples if you wanted to go ahead and practice. But what they were doing for homework is just the summer job, or not summer job, science fair, the science fair that is there. So let's make sure that you understand what it's asking. Savannah and Nate won first and second. So Savannah won the first place and Nate won second place. And so they have to share the cash prize. So the second place winner receives $3 for every $7 that the first place winner receives. So we have to decide, the $3 is obviously part, right? But we have to decide, is that $7, is that my other part, or is that my total? So receives $3 for every $7 that the first place winner receives. Hopefully you're saying that this is part and that this is also the other part. So this is the second place, this is the first place, and so together, out of every $10, this is sharing 3, the second place is sharing 3, and the first place is sharing 7, okay? So it says write a part to part. I would love for you to write both part to part ratios, okay? And then I would also love for you to write both part to whole ratios. Okay, and then down here it says if Savannah and Nate share the $100 prize money according to the rules, how much money will Savannah receive and how much will Nate receive? So it's kind of like that whole table. They're asking you to justify your answer by using at least 2 of the following representations: words, pictures, or tables. And again, that is exactly what we were doing here: words, pictures, and tables for the activity during class. Okay, so I'm hoping that this has helped you, and I hope you feel better.